some of the questions on embedded system. So question answer. So what is embedded system? So embedded system is the combination of the hardware and software designed for specific tasks. Examples like washing machine, microwaves, and automotive issues. What are the main components in embedded system? Microcontroller, microprocessor, memory, input and output interfaces, and software and RTOS. So these are the main components involved in the embedded system. So here, microcontroller, microprocessor is the brain of the system. Memory, we have the RAM memory and ROM memory. Inputs and output interfaces are sensors and actuators and some of the communication ports. And software and RTOS, it will provide the control and it will give the accurate response and real-time response on time. What is the difference between the microprocessor and microcontroller? Microcontroller is, it includes the CPU, memory, and the IO on single chip. It able to perform specific tasks and low power consumption. What is a microprocessor? Microprocessor is requires external memory and IO. It is a general purpose and high power. And what is it? The real-time system. So can you define the real-time system? So real-time systems are designed to perform specific tasks within a specific time frame and critical for the applications like medical devices and automotive control system. And what is the use of interrupts in an embedded system? Interrupts allow the system to pause the current task and execute the high priority task, ensuring timely response to the external events. Explain the role of RTOS in embedded system. RTOS, real-time operating system, manages the task with precious timing. It ensures that task scheduling, we have a preemptive and cooperative inter-task communication. We have the semaphores and queue and real-time deadlines are the one part. And how does polling differ from interrupts? Polling is a continuously check the status of the device and consuming the CPU time. Interrupt is triggered only when event occurs and saves the CPU resources. So these are major two definition for polling and interrupts. What is the importance of watching time? Watchdog timer. So watchdog timer, it will reset the system if it is detected that software is not running as expected and preventing the crashes and system hangs. What is the difference between volatile and non-volatile memory? Volatile memories, data is lost when the power is off. Non-volatile memories retains the data even without power. How does embedded system handles multitask? Using RTOS, tasks are assigned priority and managed through it. And we have a preemptive scheduling where the task interrupted by the higher priority task. And we have a task synchronization, that is a semaphores and mutex. These are the OS concepts about the primitive scheduling and task synchronization. What are the challenges in designing the embedded system? We have limited resources, optimization of the lower power and memory and processing, and real-time constraints, meeting the strict time, the deadlines, and hardware software. We need to ensure that the communication between the layers are working correctly. And how do you optimize the embedded software? We need to reduce the memory usage by optimizing the data structure. We need to use low programming language. So it should be um, timely, responsible, and we need to ensure that the tasks which are critical, it should be it should be accurate and real time and on time should be activated. The functioning of the logic or the hardware or software, it's very important, and that should be designed in a lower level language. So and moreover, the minimizing of the power consumption is a uh, one factor. And how does memory mapping works in embedded system? Memory mapping assigns the specific reason for code, data, and peripherals to enable the direct access by the processor. What is the difference between uh, hard, um, hard and soft real-time systems? So hard real-time, missing a deadline leads to the system failure, and soft real-time, missing a deadline is undesirable but not catastrophic. So like examples are the hardware video time, hard real time is the spacemaker, soft real time is the video streamer. What is the variant coding in a automotive embedded system? So variant coding, not only in automotive, like it is applicable in all the electronic devices which is operating uh, the software in it. So variant coding involves customizing the software functionalities based on the hardware variant and the regional requirement without rewriting the entire code. Just we are doing a small modification and we are making the software to use for multiple hardware resources. So explain calibration and its roles in embedded automotive. So calibration ensures that system operates correctly by adjusting the parameters like engine control or sensor sensitivity during the development and maintenance. How do you debug embedded system? By using some tools like JTAG and logic analyzer and some of the simulators. We are able to debug via the analyzing the logs from the issues, and we need to go with the step-by-step debugging by using the breakpoints. What is the difference between the firmware and software? So firmware is specifically the low-level code that directly interacts with the hardware and stores in the non-volatile memory, like ROM and flash. Software is nothing but high-level program we are executing on the top of the operating system. That is designed for general purpose task. That is all about the firmware and software difference. What are the common embedded system applications? Like we know that consumer electronics, smart TVs, and smartphones and cameras, automotive systems like ECUs, electric engine control units, and the others are advanced driver assistance systems, medical devices, pacemakers, and update glucose monitoring, industrial automation like PLCs, CAD systems. What is the GPIO? GPIO is the general purpose inputs and outputs. A digital pin, on the microcontroller, that can be programmed to the specific input to read a signal and to send the signal. So what are the steps in development of embedded system? So analyzing of the requirement, we need to understand what is the function and what is the performance it should be required on the hardware level. So we need to understand on the hardware requirement and software requirement and the functioning. Then we need to design. So that will be a part of the system design, the selecting of the microcontroller or the peripherals or the code is programming which need to be written. And then we are developing the hardware and software accordingly, and in case of firmware, we usually write the same firmware in low-level language, and then will be a part of a testing. We need to verify whether the functionality is working, time its response or not. Then we are deployment. Deployment will be we are integrating with the final product and validating on the real world condition. What is a bootloader? So bootloader is a small program. Usually it available in the laptops and the mobile phones as well. So that bootloader is the small program that installs the hardware and loads the main application firmware. So that is a major important where it loads the main application firmware in the bootloader. It enables the features like firmware updates and secure boot and all. It will be updated. What is the role of timers in the embedded system? Timers are used for generating the time delays, counting the external events, and creating the periodic interrupts like pulse width modulation for motor control. What is the difference between standard embedded C and standard C? Embedded C interacts directly with the hardware using the device-specific libraries. Standard C focus on general purpose programming with no hardware dependency. What is the debouncing and why it is important? Debouncing is specifically the mechanical switches where it will switch the information or like filtering the repeat signals. So whichever we are getting it from the electronic components or the that will be repeated signals from the physical vibrations. So mainly the debouncing ensures that accurate signals detected from the mechanical switches by filtering out the noise and repeated signals caused by the physical vibration. How do embedded system achieve power efficiency? Using low power modules, sleep mode, optimizing the code execution, selecting the energy efficient hardware component, employing the Dynamic voltage and frequency scaling. DVFS means the dynamic voltage and frequency scaling. How do memory allocation works in embedded systems? That is a static allocation. Memory is allocated for at compile time that is suitable for system with the periodic needs. Dynamic allocation, memory is selected at runtime, but execution use can lead to the fragmentation. What are the different types of sensors used in embedded system? Temperature sensor, that is the thermistors and RTOS. Pressure sensors, strain gauges and piezoelectric sensor. Motion sensor, accelerometer and gyroscope. Proximity sensor, infrared and ultrasonic. What are the different types of inter-process communication IQs in embedded system? Message queue, where it will exchange the data in the form of messages. Shared memory, multiple process, where it will access the same memory, and semaphores and the mutex synchronize the task and prevent the resource conflicts. How is security handled in an embedded system? Use a secure boot to verify the firmware integrity, encrypt the communication data, and employ the hardware secured models. So how would you design embedded system for a temperature control oven? So here the temperature sensor will take the feedback. Actuator, it will control the based upon the heating or the temperature sensor feedback. Whenever the heat increases, the actuator will respond. It will generate some of the pulses that will be checked, and the control algorithm. So PID control for maintaining the set temperature. So the heat will be generated. That time the motor fan will start. The cooling will be started. The fan here is a cooling one, which it will cools the heat and it reduce the heat. And that information we can monitor on the LED connection if you are connecting it. How would you debug an embedded system that the intermediate files? So as we know, the debugging is mainly analyzing the logs, identifying where the failures or the problem is occurred, and using the oscilloscope or the logical analyzer, we are able to monitor the hardware signals, and we are able to perform the boundary testing. We need to ensure that the edge values are correctly checking the valid and invalid values. So that's all about the embedded questioning answers.